Aloha, Richard Halverson here. This is ITS228, and today is February 10th. Let me share my screen. And here we are today around here. So we're into linked lists, and let's see, I'm going to go over the assignment. I finally finished assignment 3, and so I'm going to go over that. And I think we've been zipping through this stuff pretty quickly. I might make some adjustments to the syllabus. However, we are going to start getting programming assignments more frequently, so maybe we'll slow down and I'll spend some more time on those. I did want to point out to you, I want to show you that now when you go to cansit.in, where you would say when you could sit into a class, I've posted my schedule for the week, because if you want to try to meet with me sometime outside of class, you can see that the darker times are times that I are around. The really light ones are if I have meetings and so on. And so also, I'd like to point out that another good time to see me if you have a question is right in the beginning of class. You can come, and I won't start the recording. If you're here at the beginning of class and you have some questions and you don't want them to be on the recording, then that's a really good time, because I can just always start the recording later. And then after you're done asking the questions, you can take off. Okay, so you can watch the recording later. All right. So anyway, I just want to point that out. I clicked on the playlist to see what the last video was, and and I see that we got to the 4.10 of the chapter. So here's where we are. Yeah, here. And so let's take a look at chapter linked lists, and then I'll start with the assignment. Okay, so we're in let me close up this linked lists. Yes, linked list abstract data type. So in this class we talk about abstract data types a lot, and what that is we have sort of a visualization of a data type and how it operates and the kinds of things you can do with it, and a linked list is one where whenever you're at a particular point or element in the list, you can easily go to the next one, or depending on how it's designed, you can go to the previous one, and so on. And then there are some other methods that go along with it, and that's really what this chapter is all about. So we spend a lot of time, of course, thinking about where's the is there a diagram of a list? Singly linked lists here. You see, we see diagrams like this, and how they're actually implemented with coding. When you're actually writing the code to do it, that can be done a number of ways. So anyway, we spend a lot of time in this chapter, of course, talking about linked lists. When we go, let's go to the and these are different ways of implementing. These are different styles or different forms of the linked list abstract data type, singly linked, doubly linked. But then the implementation of them underneath can be using nodes, creating a node type. Let me come up with Python singly linked lists. Is we define a node type that contains some data, and then this link to the next node in the chain. Okay, and so and then the head of the linked list, the starting point, or simply contains 2 links to the head of the list and to the tail of the list. So when you add nodes onto the tail, it gets, this thing changes. If you were to push new nodes onto the head, then this thing would change, and so on. And so once we've defined singly linked and doubly linked is a little bit different because it's got a back link and a forward link. This is what the head looks like. Then these functions of inserting and removing from the list, they're a little bit different because you've got two links to take care of. And this shows you how you implement these things in Python. If you were to stay with this node pointer paradigm, forward link and back link sort of when we are the way that we implement the list. And I'm getting at something here. I'm going to get there. We talk about traversal, sorting. Now, and then common uses or extensions for linked lists include this stack type, whereas you know a stack works. When you add something to the stack, it's added to the top of the stack, and when you take something off the stack, you take it off from the top of the stack. So it's like the last one that was put in is the first one that comes out. Queue is different. The operation of a queue is you add stuff to the tail end of the queue and you take stuff off the top of the queue. You enqueue, add stuff to the end of the queue, and you dequeue, you take stuff off the front of the queue. And so you of course can implement these with abstract, with the linked list, with any linked list abstract data type by creating these functions, adding to the queue, taking off from the queue. And then there are usually these three other ones where you want to look at, not take off, but just look at the top of the queue, the front of the queue. You want to know if the queue is empty, and maybe you want to know how long the queue is. This is a true false thing. All right. Now, then what this book does is it goes and gives you Python versions of those stacks, Python versions of those. And here in 420, it gives you a complete Python program and explains it all for stacks and queues. So here it gives you the stack implementation using this linked list class, and the linked list class I think is defined earlier. Yes, it's defined up at the top. And so you import them in, you import this node class and you import this linked list class, and then you can use them. And so here you're using the linked list class to create an instance of a linked list. And so here, this is a stack class. And so if you're going to create an instance of a stack, like right here, you're going to create an instance of a stack and you're going to call it num stack. And then you're going to push some stuff onto the stack using this push function, push method. And then you're going to, you know, do you actually take stuff out? Yes, you're going to pop off the top item and show what that is. And then you're going to display out the stack. Okay, so you're going to push a bunch of stuff out on the stack. You're going to display out the stack. You're going to pop the top item off the stack, and then you're going to display out the stack again. So, you know, you're kind of testing. So here you're displaying out the stack after you push these in, and then you're going to pop off the top of the stack. And then after you're done popping off the top of the stack, that's what's left. Okay, so this shows you that code. We can go back and look at what the linked list code is, but I'll just tell you, this is the queue where we add stuff to the queue, we take an item off the queue, and then we display it out again. And here, this shows all the code, but it also shows, you know, all of the classes. So here we start out by looking at main, and then this is the stack class, just like what we just saw higher up. The queue class, this is the linked list class. And it does these basic linked list operations. You can append, you can prepend. This appends onto the ends, appends onto the beginning. This inserts after a particular node. This removes after a particular node, and so on. And then there's this, at the very bottom here is this node class that you saw before. It's got the data, and then it's got a pointer to the next one. So this is using a singly linked list. Okay. So I wanted to show you that, and then one last thing I want to show you is the next section here on Deques. Okay, there's a Deque abstract data type, which kind of combines two of them, combines both functions. Items can be inserted and removed at both the front and the back. So you can push onto the front, you can append onto the back, you can pop off the front, and you can pop off the back. Okay, so it's like both a stack and a queue. So it does all those things. And so these are the common operations. Push front, push back, push front, push back, and then we want to maybe peek at the front, peek at the back. We want to look and see what's there, but not take anything off. And then know if it's empty, or know how many items are in the deck. Yes, it's in the queue, but on the stack, so it's probably in the deck. All right. So what's the assignment? Let's look at the assignment. Assignment 3. I think I can get you started on this. Okay, so it's pretty easy. The first part, you're just going to take this code. You're just going to copy all these files over onto your server and get it running. That should be just like really easy. You're going to simply copy over all the files on your server, all these files, and make sure they work. Part 2, you're gonna this is the most abstract part, I guess, if you want to say, but it turns out that it's really easy. Okay. The second part is, instead of using linked list and node classes, let's just use the Python list type. Okay. And when I was going through all of this, I sort of knew abstractly that Python, there's a lot of this stuff that we really don't have to learn, or we learn it a different way if we're doing it using the Python language. And it turns out that linked lists is one of them. Okay, so what we're going to do is, in the second one, you're going to get rid of linked list, and you're going to get rid of node, get rid of those two classes, and then you're just going to modify stack and queue. So it doesn't need to use node and linked list, it doesn't need to use those, but it still operates the same way. It still gives you the functions. It still gives you these functions, push and pop. You notice this doesn't implement is empty or get length or whatever. It just implements push and pop. That's fine. And so that's for the stack, and then for the queue. You see for the stack and for the queue, the first thing you do is you create an object. You create an instance of a linked list. Of an empty linked list. Okay, and then to push something on to the stack, you're going to push this onto the stack. So then you're going to create a new node, because the linked list has nodes that store the data part of the item. The node has the data part of the item, and then the link to the next node. And so you're going to create a new instance of the node. You're going to create a new instance of a node, and you're going to initialize the data in it with this new item value here. And so that's what this new node is going to be. And then you're going to prepend, because we're using a linked list. We're going to use the prepend function of the linked list to add this, to link in this new node. And so if we look over at the linked list, let's see, can we get a linked list from here? Yeah, I guess we can probably look at this one. We have append and prepend. Prepend. So this is the prepend function. Let me just go back to this thing, and we can look and see what the prepend function is. So go far enough. We can just look in here and see what the prepend function is in linked list. So we use the prepend. We have at our disposal the prepend function, the append function, the insert after, and the remove after. Okay, so that's what comes with linked list, and we use those to implement stack. So push uses the prepend and pop uses the remove after, whereas with Q, for Q, the NQ, that's to create a new instance of a Q. The DQ function uses the remove after, and the NQ function uses the append. Okay, so that's how you implement these stack and queue abstract data type methods using the linked list, using a linked list class and what comes along with it. And what we're going to do is, instead of using this linked list class that we have to build, we're just going to use the Python list. Okay, easy peasy. Go. So over here, you're going to, instead of, in the very beginning, instead of having this, you're going to just do this, where it's this is going to be initialized using the Python list function. And then after that, you need to go in and change, get rid of this crap, and instead, and don't use the, well, my word, it might be exactly the same for this one, because you do use the, it is the append method that comes along with the Python list type that you use. So the hint here is that you get rid of this, and instead of putting new item, you put new item right there, and then that's it. For DQ, you are removing something. What does this DQ'd item? Oh, because you're taking something off of the very front of the list. You're taking something off the very front of the list. Well, there is a Python list method for taking something off the very front of the list. Oh, this textbook does not have. See, this is a later textbook. This is not the same textbook as your last textbook. So I have to search for it. Python list methods. So let's look in here. Okay, here they are. There's append, clear, copy, count, extend, index, and so these are remove. Okay, here, pop. So this takes on an argument. Right. So this isn't a good. This is not a good list. Let me just go back. The problem with that is it doesn't say if it requires a parameter. Let's look at the next one. Okay, this doesn't either. All right. So anyway, I guess you can just tell by the text. by the context. What did I just do? Okay, let me pop 2. So this is going to remove the element at index 2. So anyway, that's so you want to remove the element at index 0. That's taking something off the head of the list, is removing something from index 0. So that's what DQ would be. And so it turns out that you don't even you can just say, well, anyway, this, it ends up being, these little methods end up being more simple because you're not having to deal with the linked list abstract data type, class that is defined sort of underneath here. And the reason, okay, so this, it's actually only this way with lists because Python has a built-in list type that does everything that a list abstract data type does. So with lists, it's easy. With lists, it's simple. But as we get further on, trees, there's no built-in Python tree abstract data. There's no built-in Python tree type. So with trees, we actually do have to use these techniques where you have nodes and you have links. And as you would imagine for a binary tree, you have a node, and then you've got a left link, a left child link, and a right child link. So but this here is this is a good example to sort of teach the concept of an abstract data type, and you really you use the data type in ways where the implementation of it doesn't matter at all. So the fact that we can just replace these classes with our own classes and everything above it works the same, pretty much, is sort of the idea behind this assignment. So what I have you do is you modify those you create a stack2.py and a q2.py that are copies of the stack.py and q.py, and then you make the modifications starting with replacing this with this at the very top. And then when you're done, you're also going to create a main2.py, and I just give you that code here. And this code looks almost identical to main.py, except for it uses the fact that you're using a stack, a list, Python list data type instead of the linked list class. So you have created a stack2.py and a q2.py, and inside there is the stack class and the q class. That's very similar to main.py here. You have from stack.py, from q.py, you import these classes. Okay, so this is the class name and this is the file name. So that's why it's that way. This is the file name and this is the stack. And then these are exactly the same. This is the same, but instead of using a while loop and having to start with a list, the head node, and then looping through node to the next node to the next node to the next node until there is no next node. So that's looping through, starting from the head, looping through until you follow the link down. Each time you come to a new node, you print it out, and then when you reach a node that doesn't exist, then you're done, and then you print the new line. That's what you do here. You just start out from the first node and you go through the list. This is built into Python, and you print out the node, and when you're done, you print out that. Okay, so it's the same thing. And here, okay, so that's it. And so so if you get this to run with your new Q stack 2 and Q2s, then you know, that should be fine. Then you've probably got it working. This is very simple test. You really should. We're going to spend more time coming up with methodologies for testing your code, but these are we haven't touched on that at all. It's testing should take way more time than coding. Okay, but in this class, but in these classes so far, we've focused on this, you know, the skill and technique of coding. But and testing is more a rigorous process that you gotta. It's just, you gotta do it. So here, so the only real difference is the way we traverse through this list, and in this case, we would call it a linked list. The way we traverse through this linked list. All right, so that's the second assignment, part 2, and it looks like the hardest, but it's really the easiest, because once you figure out that all of these things are built right into the list type, the Python list type, you just got to figure out which are the right Python list types and the parameters or the arguments for them, and then this thing just works pretty much. All right, well, in fact, it does. All right, the third one is actually implementing a deck. And so I want you to create a new file called deck2.py. There's no deck.py. I thought about making a deck.py, but let's keep it simple. So you create a deck2.py, similar to stack2 and q2.py, but you have it implement the deck abstract data type. And I'd like you to implement all the operations that are described in 4.2.1. And I want you to implement them like you would implement them in the class, in the Python class, you know, syntax. And that is the methods, you know, the methods get, you know, it's like the name of the object dot method. And then if there's an argument that's connected along there, if we look at 4.2.1, 4.2.1 is down here. We see that it's described this way: push front, and then the deck, the object, and then this is what you're pushing into it. And this is just the way it's described in this textbook. And same as the stack operations and the queue operations are described like this, with this you know, capitalization thing there. But I'd like you to implement them this way, just like the ones in stack and queue, in stack 2 and q2. All right, so you're implementing push front, push back, pop front, pop back, peek front, peek back, and returning true or false if it's empty, and returning the length of the list right there. Real easy. Okay, so now up here for 3.2, I tell you to put this in there, but I'm not going to test this. Okay, I'm actually only testing what's inside here and what's inside here. Okay, so you can mess with this all you want. You should, because you really should test your classes in here in other ways. This test is kind of dumb, because you know it ends up looking the same for each, and I'll show you that there's a half hour left in this period, so there's time for me to actually do this assignment. But I want to go over it first, because then maybe once I start it, you know, you'll understand it, and once I start showing you the assignment in this class, maybe you'll just be able to take off and do it yourself, and you won't have to like pay so close attention to it, because that's really what the best thing is. But I'll get you started on all these things. So now for the 3.3, 3.3 though, I do look at your main.py. So make sure this thing still works. When you're all done with this assignment, make sure this thing here still works. I tell you to use main2.py to test your Deques2. Okay. So that means in your main2.py, you're going to have up here from Deques2 import Deques. You're going to have that there. So my Autograder is going to look for that, and my Autograder is going to look for my Autograder is also going to look for an instance of every one of these in there. You know, because if you're going to thoroughly test or to minimally test your methods, you have to at least call them once and see the result. Okay, so I want to look there. I want to look in here and see that you've modified your program to be able to test these. And all I'm going to do is see if you use those. Not much more than that, but if you're going to go so far as to put these in there to pass the test, you might as well, you know, display them out and confirm. Because remember, I'm also testing these methods directly. So I don't have the Autograder up yet. The Autograder grading assistant still only does 1 and 2, but that's okay. I'll have it up in the next few days. But in the meantime, you know, in the real world, you're not going to have an Autograder to test your code. You're going to have to figure out how to test your code yourself. And by the end of this class, we're really going to have to be able to do that well. I think might be the last outcome somewhere. So so let's get started with this. Let's go back to the assignment, and I'm gonna start up my server, and that would be our richardh.its228.com. I haven't done and then I'm going to go to Cpanel. I think this does automatically. Go over to the secure server. It does. And I'm going to log in, and yours is different, of course. And I'm going to see what I have there in my file manager. Go to assignments. And I've got 1 and 2, so I got to do 3. Let's what's a good way to do this? I like I don't want that. Where does this go if I do this? No, I don't think that's going to do it for me. All right, so I want to be able to see the assignment. I'm going to break this off. Now I'm going to make it smaller. Go like this. Put this down here. And I'm going to go right file manager and put this up like this. All right, so in assignments, make a directory named 3 and then copy all these files over from there. Okay. All right. So I'm going to make a 3 folder 3. I'm in assignments. I'm going to make my folder 3. I'm going to go in there and I'm just going to make them manually, and then I'm going to copy them over manually. I think that should work. Hope that works. I could copy them down. I'm just gonna do it that way. So I'm gonna make a main.py. So I just do this. That's nice. I'm gonna make a stack.py. Oops. Oh, okay, good. That worked. I'm gonna delete this. So let's try again. Stack.py. I want to make sure I don't mess up. Okay. And I'm going to make a q.py. And I'm going to make a linked list node.py. And I'm going to make a linked list.py. See, if we were, I'm teaching ITS228 in the summer at Manoa, and it's same stuff. Okay, and but I got to go through this linked list stuff, and there's no, and it's Java, so I got it. It's just there's no list type in Java, so we're forced to do this linked list thing. But this is kind of a treat to be able to say, well, this is a standard Python feature that is much better than any other programming language. All right, so, and then I need, okay, so that's it. So let's go now to, I'm gonna go here and go to, let's do this. I need to go to here. I need to go to here, and I gotta copy main, copy. Main, edit, paste, save changes, close. Okay, and next is stack, Control A, Control C, stack, edit, hit Control V, save, close. I'm just closing it so I don't get mixed up. Next one is Q, drag, Control A, Control C, over here, go to Q, edit, paste, save changes, close. Next is node, copy, node, edit, paste, save changes, close. The last one is, I hope this works. Control A, Control C, linked list, edit, paste, save changes. All right, so close. Okay, so now I've got those there, and I'm going to go over to main, go down to advanced. I'm going to open up the terminal, and I'm going to right click open, because this, when I click on this one, it takes me away from the Cpanel. So I'm going to open up in a new link, and here I am, my terminal. ls-l lists the directory, and I'm going to go into assignments, cd assignments, and I'm going to go into, if we list ls, well, I can do dir like DOS. 1, 2, and 3 are my directories. I can do cd3 and ls-l, and we see these are my files. And if I do Python 3, remember Python 3, main.py, and it is boom-bitty boom-bitty boom. Oh, and look, it works. Fantastic. All right. All right, so that works. Very good. Now we got the first one done. This will be up soon. All right, so what's next? Let me go to maybe do this. And okay, we've done that. Let's go down for replace the linked list class with a Python list type. Create 3 new files, stack2, q2, and main2. Okay. I give you the code for main2, so you just need to create a main2. So I'll do that. Main2, main2.py. Create new file. There that is, main2. And then, oh, cache. Guess that's if and then I'm gonna create a stack2 and q2, but I'm gonna make them from copies of these other ones. So I'm gonna go back over here and I'm gonna start with stack, and I'm gonna copy. Click on copy. And what do I want to name it? I think I gotta put that slash in there, and I gotta say stack2.py. Copy. Make sure you put that slash in there. And so there we are. And that's going to look the same as stack. And I'm going to do the same thing for Q while I'm at it. Copy slash capital Q UEUE 2.py. On Linux servers, case matters. If you're using your Windows machine and you're just running this using a DOS prompt, doesn't matter. All right. So now Q2 is there. And all right, so they define the same classes, however, they okay, so all right. All right, I'm going to copy over the main2 also. I'm going to do that right now too. So this is main2. I'm trying to think about how much I'm going to tell you, and then you have to do the rest yourself. Copy this. Copy. And then let's go to up here, and I'm going to paste this in the main2. Control V to paste and save it. And I'm going to leave this one open because I'm going to what I'm going to do is I think I can do this. I'll do one of them. I'll do the stack, okay, and then you do the queue, and then you have to do all the decks, okay. You have to do all the deck ones. So, but I can do the stack one, and I can make this 2, but then I can put the queue one back to the old one. No, I can't do that, can I? Never mind. I can not test. I cannot. Why? Because the for loop is different. The for loop is different. So all right, I'm just going to start. Okay, so this is main2, and let me go to so let me start by messing with stack2. Edit. All right. So the first thing it tells me to do is replace this with this. Okay, so I'm going to do that. I'll just do it up here. Can I make this bigger? All right, so the first thing is instead of making it a linked list class, I'm just going to go like this. I'm going to use the Python list class, a Python list class, okay? And I don't need these things up here anymore. I don't need these. Okay, I'm using Python list class. Okay, so first thing is is so I've got this list. This let's follow along. Where's main2.py? The first thing we do is we create a new instance of the stack, and it's going to be called num stack. And then we're going to call the push function 3 times, and then we're going to print it out. Okay, so this thing is going to have the push function working. It's going to have creating a new stack working, and it's got to have the push function. Then this is what's got to be, that's what's going to be pushed. Okay, so so what is a list push function? Well, list pushing is, what is pushing? We're pushing onto the front of the stack, right? You have to get that straight in your head. And to get that straight in your head, I go to this, oh no, I go here. I go to definition of a stack. And yeah, so it pushes it at the top, which is the front. So it pushes it on the top, and it pops it off the front. I guess top is synonymous with front. You know, it matters because you can always implement a stack where you push it on the back and you pop it off the back, and it would function the same as a stack. But if you were to print out the list, you would print out the state of the stack, you'd be confused because you'd think the back is the front is the back. So that's my only point there. But let me let me go back to here, and so I'm going to push it on the front of the stack. So I got to look at the list function for these, all the list functions, Python list functions. Let me go back to this other one. Oh, wait a minute. Oh, well, they're right here. Python. Okay, so I'm going to, this appends onto the end of the list. I want to insert an element into the list. And insert at index 3 an item. Okay, so I'm going to use this insert function, and I'm going to make that be, I'm going to get rid of this. I don't need any of this anymore. All I need to do is insert at item 0 because it's at the top, and insert new item. We don't have to deal with nodes anymore. We're just going to go right in. When I insert something onto a list, it creates like a new node, a place for it, and it puts the data item right there, and all the linking is taken care of underneath. Okay, so that's all I got to do for pushing. And for popping, I am removing from the position 0. I'm popping off of position 0. Is there some sort of remove? I think this is removing a node that has a particular value. I think this popping is where I can actually give an index at a given index from the list. So here, like for example, here, pop 2 will pop 0, 1, 2. I must pop the 5. Yeah, pops the 5. So I'm going to pop the 0. I want to pop the 0th element. So that would just be, oh, and then I want to return that. So I want to return the popped item is going to be self list pop 0, popping the 0th item, and that's popped item. And I don't need that anymore. So pop, and then I can return them out. Okay, that should work. Easy. Okay, let's see if this works. Save changes. Let's go back to main2.py, and so this and this and this should work, and this is going to pop that off, and but the queues won't. So I'm going to comment out down from the queues. So I'm going to do bump, bump, bump down to bump, bump, bump. All right, so I've commented out all the queue tests. I'm only doing the stack test. So I don't, this is not going to mean anything, but it's okay. I think I can just leave it there. So I'm going to save the changes here. I better save the changes here. From the lists. Yeah, I guess that's kind of the same thing. So let's run this. Let's go to the terminal. And I'm going to say, let's do ls-l to make sure everything is there. And it is. So I'm going to run main2, Python main2.py, and it should be the same as this part up here. It should be the same as this. Oh, what's the problem? I didn't do Python 3, I did Python. Python on this server is Python 2, and I have to leave it that way because of some other stuff. So you have to make sure you type Python 3 and not just Python. So Python 3. See, that's a syntax error in Python 2. Python 2 is a lot different than Python 3, by the way. Main2.py. All right, so look, is it the same? 11:56:45, 11:56, and popped 11. Okay, 56:45. Okay, look, it looks the same. Now, okay, so good. I will let you finish. So I've done stack 2, and you can do Q2. So you've got to go in here, and you've got to, do that. And then figure out what the thing is for that, and figure out how to do this so when you take something off the queue, you have the right thing over here to take off the queue. You won't need this, and it should just return, and it should be the same. You can get rid of this. Okay, so that's queue. All right, and so I'm done with. All right, I'm going to leave this here because I'm going to. Okay, and that's main2. All right, so the last part is creating this this deck. Create a new file, deck2.py, that defines a deck class similar to stack 2 and Q2. 5 minutes left. Implement the deck. Implement that. Modify this to test that. Okay, so you can start by going. I'm just gonna start with stack 2. I'm just gonna start with that. I'm gonna make a copy of stack 2. Call it deck py, deck2.py. Now in deck2.py, we're gonna create a class called deck, and the init is gonna be it's gonna be a list. And what are the methods gonna be? Well, let's go back over here and copy this. copy, and I'm going to just do this here. I'm going to go see, we're not going to need any of that, but let me just go def space. I'm just going to do this. I'm going to paste that, all that there, and I'm going to do it's got to be self, comma, and it can be oops. And this can be a colon, and I'm going to do it on, go down here. I'm going to say pass, just because I want it to compile correctly. And I'm going to go back here and I'm going to say def space. Okay, so I am replacing delete. So I'm replacing this. I'm going to be replacing this with this. Actually, I can just replace the comma with this. Okay, see what I'm doing? I'm going to copy that, and then I'm going to replace, I'm going to go start from the back. And I'm going to replace the comma with that, 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 and replace the comma with that, and replace the comma with that. So I've got all of these methods that I've got to implement. I should have done something about this. I got to put the selves in here for all of them. And this one is just okay. And this is the, we got to do this one too. Return. What's the length of a list? I don't even remember. Oh, it's bad. It's here. Python. I know where it is. Python length of list. You know, after you learn lots and lots of languages, they're all a little different, and a lot of them are the same. You know, so it's just that. So you put the len around the whole thing. It's not a method. It's not a method of the list. It's a function that's a function that can take as a argument an iterable, and it'll tell you how many there are. All right, so that is right here, and so I'm going to return the len of self dot list. And by the way, the self's got to be in there too. So that's the end of that. And there is no push, but push is the same as push front. So I'm just going to take this and I'm going to put it there. I'm sure that's right. Push front. Wait, sure. Oh, wait, what's going on? Oh, X. Well, maybe tell you what, I'm going to make this new item. Okay. So that's push. That's the same as push front, and then pop would be pop front, wouldn't it? Pretty sure that's right. Okay. Now you're gonna have to make sure it's right. I guess if I later figure out that that's not right, I guess I'll tell you. I guess I have to tell you. But anyway, so you have to go in and fill these in, and then you have to test it to make sure that it works. And my Autograder is going to bring your program. It's going to bring your what does my Autograder do? It's going to import, my Autograder is going to import every one of these. and I'm going to test the methods. I'm going to test each of these classes, and I'm going to, no, not this, not main.py. I'm not going to test main.py at all, but I'm going to test the methods, the classes and the methods that are defined in Deques and link in Deques in all of the ones that you've added. And then I'm also going to parse main2. I'm just going to look in main2, parse it to make sure that you make a reference to all of the methods in the classes that you've defined. All right, so that's pretty much the end of assignment 3. When you're all done, just leave everything the way it is, and I will I go through and at the very end of the semester, I go through and I run the Autograder on all of the assignments, on all your stuff, to make sure that all your scores are recorded, because believe it or not, some people don't, it's fine, they don't really use the Autograder because they know how to thoroughly, they write their program, they thoroughly test their program, it works. They might not use the Autograder the last time. They might use the Autograder the second to last time, and they see there's an error, they fix it, and then they go off and do something else, and they never run the Autograder the last time. So I make sure that it's run. So anyway, hope this helps. Catch you next time. Thanks for watching.